Let's look at another function, specific function from trigonometry, to analyze what the first and second derivative can say about this function. Before we begin, I want to remind you that it is very important to have your trigonometric values memorized, either from the unit circle or using a famous acronym like ASTC. Memorizing your trigonometric values from trigonometry gives you the possibility to learn calculus. So keep that in mind. Very, very important to memorize your trig values. Let's go ahead and begin. Let's find the intervals of increasing and decreasing for this particular function. Function is probably some form of a sinusoidal function. We're going to apply the chain rule here. The derivative of the outside function evaluated at the inside function times the derivative of the inside function. And then we need the derivative of -2 times sine of x, which is simply -2 times cosine of x. Now we factor as usual because that's what algebra tells you to do, and we react to it. We use algebra as a reaction when we study for calculus. And this is in reduced factored form. Notice the denominator is 1, so there won't be any type 2 critical numbers. We're simply going to be looking for type 1 critical numbers. So let's look for type 1 critical numbers. Type 1 critical numbers occur when the first derivative is equal to 0, and we end up solving this equation for the letter C. Notice there's 3 factors that multiply to get you 0. -2 is not 0 already, so we're only left with solving these 2 equations for the letter C. So critical numbers on the interval 0 to 2 pi. Our first critical number would be at the angle pi over 2. And from trigonometry, the next critical number will be 3 pi over 2. And like I said, this is simply from memorizing your trig values or the unit circle as knowledge. I mean, you want to memorize it so well, it's like reciting your cell phone number. Notice this third critical number is actually the same as a prior one. So I don't think we're going to need to test around that one again. We only need to show this, show that third critical number once, because we already got it from the first equation, or the second equation, I should say. Actually, it is the first equation, because this right here is an inequality. That's not even an equation. So we got it from this equation. We got the critical number C2 from this first equation here. Let's put this on a number line so we could find our intervals of increasing and decreasing. Now, in this particular case, the number line starts with a closed interval. So it starts with a label of 0. And then I need to create 3 intervals here. The first one ends at pi over 2. And then after that critical number, we have another open interval. It goes from pi over 2 to 3 pi over 2. And then the fourth one here goes up to the closed interval here. I'm sorry, it goes up to the endpoint called 2 pi. Now, obviously, it's not the scale. I'm not worried about scale here. I'm just worried about whether or not the first derivative is positive or negative. Now, remember to pick test values, and because this is a trigonometry problem, you're going to use your trigonometry knowledge. So you need a test value between 0 and pi over 2 radians. I would pick pi over 4, you know. Very intuitive. And you plug in that pi over 4 where? Into your first derivative, the first derivative in factored form. And of course, you know that sine of pi over 4 is root 2 over 2. The cosine of pi over 4 is root 2 over 2. So this is negative times positive, which is negative. So you can see how memorizing your trigonometry can really help in your study of calculus. Let's evaluate a number between pi over 2 and 3 pi over 2. Why don't we use pi radians? Cosine of pi is negative 1. So negative times negative, and then sine of pi is 0. So we have a negative times a positive 1. That is going to be positive. We need an angle between 3 pi over 2 and 2 pi. Lots of choices here. You might want to use 11 pi over 6. Cosine 11 pi over 6 is positive root 3 over 2. Sine of 11 pi over 6 is actually negative 1/2. But what's negative 1/2 plus 1? That's just positive 1/2. And we have positive times negative. That has to be negative. Just like that, you were able to analyze the first derivative. This is also known as the first derivative test. Now let's answer part A. I'm going to answer it way up here. Part A. We know the function f of x is decreasing on two intervals. And when we're talking about decreasing or increasing, we always talk about open intervals. There are your open intervals. And we know the function is increasing on another interval. And so we have answered part A using our number line diagram. Part B, are there any local max and local minimum values? Let's see. Let's analyze this a little bit more. So it looks like the function decrease and then the function increase. So at pi over 2, at C1 equals pi over 2, we have a local minimum because the function decrease and then an increase. And the local minimum here is f evaluated at pi over 2. So if you look at f evaluated at pi over 2, evaluate the function f at pi over 2. Cosine of pi over 2 is 0. And then sine of pi over 2 is 1. So this is negative 2. And what happens at the other critical number? The function happened to increase before the critical number and then decrease afterwards. So that has to be a local max. And if you evaluate that, you'll get positive 2 this time. Evaluate 3 pi over 2 in the function, you get 0 here. Sine of 3 pi over 2 is negative 1, so negative 2 times negative 1 is positive 2. Now I recommend that you start making a t-chart to collect ordered pairs, because in the end you're going to put together a giant puzzle and try to figure out the sketch of this function. So I'm going to go ahead and start writing a t-chart, just so that I start collecting some data values so I have a better analysis of what is really taking place You could evaluate at 0 here, and notice you just get positive 1. Pi over 2, we got something going on. We got a local min. At 3 pi over 2, we also have something going on. We have a local max. And certainly, if you evaluate at 2 pi, you also realize that you're actually at positive 1. So you have 4 ordered pairs already. The next thing you want to do is find a shape of this graph. Find out the shape. And in order to do that, we look at the second derivative.